My name is Sheila Raja. I'm from the University of Michigan Department of Electrical Engineering. And this summer I worked in the Optoelectronic Components and Materials group with Professor Stephen Forrest. My project was called The Reliability of Organic Solar Cells. This included testing the lifetime, how long normal organic solar cells tend to last. So what is an organic solar cell? Organic solar cells are made with organic materials. Most solar cells that are in use today are inorganic solar cells. This is because 1, they last longer, 2, they have higher efficiencies, and 3, they are a lot less susceptible to oxygen and water penetration. Organic solar cells, the ones I worked with, once they are exposed to even a little oxygen or water, this greatly reduces the lifetime and the efficiency of these solar cells. The type of solar cell I worked with are called the sub-PC C60 solar cells. Sub-PC and C60 being the 2 main organic materials that we used in our solar cells. So this picture that you're seeing on the slide right now is a picture of an actual solar cell that we made and tested in our group. So what makes up an organic solar cell? For an organic solar cell, you start with about an inch by inch piece of glass quartz. You coat the bottom of it with a metal. We used indium tin oxide, which is a common metal used in organic solar cells. We then put our 2 organic layers on, so sub-PC and C60. And finally, we coated it with a final aluminum metal. As you can see in the diagram, each metal is perpendicular to each other and of varying lengths in columns and rows. This is so that each intersection point of where each metal intersects is a separate actual solar cell. This way, for example, on this device that you're seeing on the screen, there would be 3 different solar cells, and so a succession rate would be higher that one of them works. So we made our solar cells in what's called a solvent evaporator. This solvent evaporator heats the organic or the metal until it becomes a vapor. Then the vapor goes and deposits on the actual solar cell that we're making, and this is done in a chamber at vacuum. So as part of our project, we had to actually build our own setup. So you can see here that this is the lamp that we used to test our material. The light came out of this cylinder through these microscopes and lenses and into the black box. We used a black box so that there would be no ambient light that penetrated our solar cell. And also we sent it through microscopes and lenses, so 1, we could focus the light so we could get a uniform beam, and 2, we could make sure that it was equal to the power that 1 sun produces. So this is a diagram of inside the black box. You can see the actual cell sitting on the metal stage, and you can see that there are 2 probes that we have in there. So the first probe impacts the bottom metal, and the second probe impacts the top metal. And these 2 probes are hooked up to a source meter, and thus there's a closed circuit that runs through the organic material. So where does the reliability part come in? Well, we wanted to test our devices every hour, and testing includes applying a voltage across our solar cell and measuring the current that we produce. And we've tested from -2 to 2 volts. Instead of having to sit there and test every single hour for up to 24 or 48 hours, we decided to automate our setup. This included writing a MATLAB program that would run our voltage sweep every hour, and thus no one had to sit all night testing our device. One of my contributions to this project was that I wrote another MATLAB program that would take all the data that we have saved in Excel and perform all the necessary calculations and graphs that we needed to successfully analyze our data. So here are some sample view graphs of the data that we produced. In the bottom right corner, you can see the efficiency. This particular test, the solar cell started at about a 1.8% efficiency and decayed within 10 to 12 hours to about 0%. Cells we made later on in the summer, because we improved on the process, started at about a 3.5% efficiency, decayed to about a 1% within 24 to 36 hours, but then stayed at 1% for about a week or a week and a half. So what are the results of our data? This project was pretty long-term, so it's not yet finished. We performed all the necessary setup, and now it's almost a make your solar cell and wait game. We hope to, in the future, test a variety of different solar cells, so make our own, or make different solar cells using different organic materials instead of just sub-PC and C60. We also hope to make improvements on our processing so we can help oxygen and water impact the solar cell less, so we can get even higher efficiencies. And finally, maybe we might hope to mimic day-night cycles, so that would more resemble the real world. Thank you.